Chapter 6.4, Inverse Functions. So first let's define what an inverse relation is. And this is a relation that interchanges the input and output values. So remember, input is x and output is y. So if we have an equation that is y equals mx plus b, for example, let's just use a linear equation, a linear function. We switch x and y, our input and output values. So instead of y equals mx plus b, we would have x equals my plus b. Next we have inverse functions. These are f of g of x equals x and g of f of x equals x. So these two are obviously interchangeable, and this is how we prove or verify that these two equations are inverses of each other. So in this problem we are going to verify that f of x equals 3x minus 5, and the inverse of, this is the inverse of f to the negative 1, it looks like, is the inverse. So we have this inverse, which is 1/3 x plus 5/3, are inverse functions. So these two equations need to be verified that they're inverse functions. So let's plug in f of the inverse of f. So f of the inverse of x equals x. That's how we're going to prove that these are inverses, that f of x and the inverse of x are inverses. So we're going to put in 1/3 x plus 5/3, and then 3, maintaining this as our x value. This whole thing takes the place of our x value in 3x minus 5, so we have 3 and then the minus 5 part. So we get x plus 5 minus 5, and we get x. Now if we do the same thing for the other side, instead we have the inverse of f of x. We have the inverse of 3x minus 5. Therefore we have 1/3 3x minus 5 plus 5/3. X minus 5/3 plus 5/3, these cancel out just like these did, and we get x. So we verified that these two functions are inverses of each other. So we have the inverse of nonlinear functions, namely our x squared equations here. So we have y equals x squared and x equals y squared. So our parent graph of y equals x squared, this is a function. But when we have its inverse relation or inverse function, we have x equals y squared. Remember, we're switching x and y. This is not a function. If we use the vertical line test, this crosses 2 points and therefore is not a function. So this is just comparing the inverses of nonlinear functions and deciding if they're functions or not. Finally, let's examine the inverse of a cubic or square function. So for this problem we've used a cubic function, and we're told to find the inverse of f of x equals 2x to the third plus 1. So we are going to switch x and y. So this is the same thing as y equals 2x to the third plus 1. Instead we'll have x equals 2y to the third plus 1. So we have x minus 1 equals 2y to the third. And basically, after switching x and y, next we want to isolate y. So we have divided by 2, and then we're going to find the cube root of both sides. That way we just have y on one side and then the cube root of x minus 1 over 2. And we can actually write this specifically as, so we keep this side, but on the other side we'll have the inverse of f of x.